All right, I think we're live. Let me just move this screen right now. There we go. Hello, everybody. How's your day? Unfortunately, no camera for today. I have this huge pimple on my nose, of course. I hope you guys don't wish to see it, so I saved you from a bad image. But other than that, my day was perfect. There are so many claims about Fable being back. I mean, it has been added to Amazon's Bedrock. I mean, not entirely sure, but I've seen some posts over X. There's another post about GPT 5.6 being added within the HTML of the homepage of OpenAI, on which we actually tried and it worked. I mean, if you try to find GPT -5 -6, you can see something with like GPT 5.6 auto or something like that within the source code of the page. So who knows? Maybe in a day or two we might see GPT 5.6 live, which I'm pretty excited. I mean, I've moved to Claude about a month ago, and I've been very happy, honestly, with Opus 4.8. Luckily enough, I had a couple of days. I mean, not really a couple of days, but more like some hours with Fable as well. Yuli, my colleague over here, also has migrated over Claude, which maybe he can say a little bit later a couple of words about his relationship with Claude, because I believe it's amazing. Hopefully, he believes the same. And yeah, let's move forward with the presentation. Again, hope you guys had an amazing day. Let's get over with another edition of the lab within David Tech. Of course, guys, the disclaimer: we are not financial advisors. You are 100% liable for your financial decisions. We are just trying to debunk the market with the tools available, and of course, if they are not available, we are building them. If you're getting approached by someone claiming to be a David Tech staff or David or me or something like that, in order to invest into some kind of, I don't know, private group or private signals or anything like that, that's 100% not us. We're never going to approach you to deposit into some kind of hidden project or private project or anything like that. If you need to speak with an official, just jump over our Discord, discord.gg/davidtech, or the WhatsApp group within the community of trader.dev, or within David's newest videos. And of course, we are going to help you with your problem. If you guys have any questions within the live stream, and also I would like to salute the 15 people watching us over YouTube, X, and Twitch. If you guys wish to join the conversation, you are more than welcome. This is pretty much like an open mic discussion within Discord. Just make sure to let me know if you wish your voice to not be recorded, so I could mute you inside the recording so people can watch it a little bit later. Other than that, at the end, we are going to answer all of the written questions if they are not related 100% to the topic of discussion. So yeah, please enjoy the show. Today's agenda, today will be 24th of June. Again, many things are happening within X, many announcements about Fable 5 return, GPT 5.6. It's already within the source code of the web page. So yeah, pretty excited. Maybe we could actually see something happening maybe today, tomorrow. So by the end of the week or Monday, when we are seeing each other again, maybe we're going to talk about Fable being added again, or GPT 5.6. Regardless, today's agenda is pretty much stacked with our friend here, Yuli, which is going to show you guys a second part of the Monday presentation. This is not a strategy release, unfortunately, but we should let him talk more about it. Who knows what surprise he has in the hat. So, guys, I would like to present to you Yuli. He's an electrical engineering teacher within our community, and actually, he's a coder inside the community, and it's also a builder of PineScript strategies and indicators. In the Eastern EU, he's a electrical engineering teacher, and yeah, he's joined David Tech for like 4 or 5 months already. He's been doing great. He also has a dedicated zone within Discord, which I'm going to talk a little bit later, because there is a new room upcoming very, very soon. If you guys can see the setup builder, of which I'm very excited to talk to you about. You can definitely see the Algo Lab, that's 100% where you can ask Yuli any question, and he's more than happy to answer to anything regards to the project. So, Yuli, my friend, how are you doing?
Hi Vlad, hi everyone. Excited to continue with the meta indicator presentation for today. And beside
Awesome.
that, everything is fine. You already mentioned my migration to Claude. I can say I'm definitely very happy with it.
Wow.
It's a really powerful engine. Let me share
Wow.
my screen in the meantime.
There's
Check the
definitely some
echo.
differences. Oh, it's good. It's good. Let me grab the presentation. So there is an introduction slide. Let me
Yeah,
just get it very,
Algobots,
very quickly.
it's echoing. Also,
Um,
okay.
if you could mute the presentation, guys, right here. Let me just give you guys. So at the bottom right corner of the share screen, there is a mute button that you must build because Yuli at the moment is sharing his screen and maybe his audio as well. So that's why you are actually hearing the echo, of which, if you're going to do that, you're no longer going to hear it anymore. Plain simple. Let me just double confirm. Oh, and also as well on mine, it was on audio. Let me just make sure the share screen is okay, Yuli, so you can proceed.
Okay,
There we go. Perfect. Scene is yours.
good. Thank you. Welcome back, everyone. So, before we begin, a quick reminder this session is educational only and not financial advice. We are not discussing buy or sell recommendations. We are discussing how to read and audit a ranking engine that we have built and presented already a part of it on Monday. So, what happened in the first session, we focused on why MCDA exists and how to configure it. We explained that the meta indicator is not a trading system, not an entry signal, and not price prediction. It is a selection layer. It helps compare candidate indicator streams so the user can decide which one deserves more attention in the current market context. Today, we move to the second half of the story, how to read the dashboard and how to trust what it is showing. So, configuration gives the engine a clean comparison set. Interpretation turns that comparison set into something useful in real time. So, this session has two goals. First, we will learn how to read the dashboard, leader, now, view, regime, confidence, candidate rows, explain mode, diagnostics, the debug layers, and so on. And secondly, we will connect the trust claims to validation evidence. So we will look at the input safety, normalization fairness, proprietary logic, regime isolation, stability behavior, and the non-repaint logic. Basically, the validation plan that I used to finish this meta indicator. So the purpose of this session is not to turn everyone into a developer. The purpose is to make the dashboard readable and to show that the engine is designed to be audited and not blindly trusted. So as I said in the first session, the indicator should give you all the necessary information by the tables, and you should be able to understand everything it does internally and why it outputs those results. So the central claim is deliberately narrow. MCDA is not a trading oracle, it is an auditable ranking engine for candidate indicator streams. So let us start with the most important reading habit. Do not read the dashboard as one number, read it in layers. The dashboard is not just only one number and it is not answering only one question. Each layer answers something different. the header layer answers what is the state of the engine right now. It shows leader, now, view, regime, confidence, and hold bars. This is the engine's headline. The ranking layer answers how are the candidates behaving relative to one another. This is where the rows show which candidate is leading, which candidates are valid, which ones are excluded, and which sources are duplicates. The audit layer answers can I understand or verify why the board looks this way. So that is where explain, diagnostics, and the L1 to L4 debug layers become useful. A lot of confusion comes from asking the wrong screen the wrong question. So if you want a quick read, use the header and summary. If you want the meaning, you can use the explain mode. If something feels surprising and you want proof, use diagnostics or debug. The reading rule is quite simple. Start with the header, read the rows second, and only open audit layers when you need deeper explanation. Now let us zoom into the header because that top row controls how every other part of the table should be interpreted. So the main table anatomy, we have the top row, which is the headline. Before you care about individual scores, read the state of the board. Leader is the visible champion out of the indicators that you are trying to compare. It is the candidate currently shown as the stable leader. Then we have the state now, which is the current life winner underneath. It can change faster than the leader when the market is noisy or confidence is too low. We have also the state view, which tells you whether the visible board is updating, held, or suspended. The regime, which tells you the price context, for example, trend, range, volatile, or mixed. Then the confidence, which tells you how much trust the engine has in allowing the visible order to change, and the hold bars that tells you how long the visible ranking has been held. The practical rule is this: never interpret a row without reading the header. A score in a confident updated view does not mean the same thing as a score in a low confidence held view. So the body rows are still important, but the header tells you the state of the engine before you interpret those rows. Also, notice that invalid or disabled rows can remain visible. That is intentional. The tool is not hiding exclusions. It is showing why certain candidates are not part of the active competition. The next step is choosing the right view mode for the question you are trying to answer. So here, the same engine can be read three different ways. There is no single best view mode. The best view depends on the question. Summary is the fastest reading mode. It gives a compact view of rank, score, role, and status. This is the best daily default when you just want to scan the board quickly. Then we have the explain, which is the best learning mode. It shows the strongest and weakest properties for each candidate. It helps answer why one row is high and another one is lower. And the last one, the diagnostics, which is the audit mode. It exposes more of the score path and rank details. This is the view to use when the results feel surprising or when you want to inspect stability behavior. So the rule is summary for speed, explain for meaning, and diagnostics for audit depth. Um, Most confusion comes from trying to answer all three questions from the same screen. So if you want speed, do not overload yourself with audit details. If you want proof, do not expect the compact summary view to explain everything. Now, let's look at the distinction uh, between leader versus now. So these two are the most important labels in the dashboard. Leader is the stable, visible champion, while now is the current life winner underneath. They can be the same, but they do not always have to be the same. In low confidence or choppy conditions, now may change while leader stays held. For example, leader may remain, let's say, weighting moving average 20, while now changes to stochastic. That does not mean the table is inconsistent. It means the engine sees a live contender underneath, but the confidence gate has not yet decided that the visible leader should change. So this distinction is very essential. Leader is the stable, visible claim, and now is the live competitive state underneath. The gap between them is often where the anti-flicker behavior is doing exactly what it was designed to do. Without this separation, the table could become a noisy scoreboard that changes too easily. With this separation, the user can see both things, the stable visible leader and the live contender underneath. That naturally leads to the next distinction regarding held versus updated. So the stability layer decides whether the visible ranking should move now or wait. Updated means confidence is high enough. The visible ranking refreshes and hold bars reset to zero. In the meantime, health means confidence is below the threshold, so the visible ranking stays frozen and hold bars continue to increase. This is not lag, it is display governance. So the engine is asking, is the evidence strong enough to change what the user sees right now? If the answer is yes, the board updates. If the answer is no, the board holds. The examples on the slideshow show how lower confidence threshold can allow faster updates, while a higher threshold can hold the same environment longer. So health is a feature that protects the user from treating weak evidence as if it were strong evidence. Once you understand health and updated, explain mode becomes much easier to use. So now, regarding the explain mode, this is where the dashboard becomes teachable. It translates score composition into plain language strengths and weaknesses. The strong column tells you which properties are supporting the candidate. For example, if strong says PA and RL, that means predictive alignment and responsiveness are helping that row. The weak column tells you what is limiting the candidate right now. That is often the fastest way to understand why a candidate is not leading. The status column tells you how the row should be treated. Leader, OK, held, duplicate, off, or another status depending on the state. So explain mode answers the question, why is this row here? It does not expose every formula and it does not need to. Its job is just to give users a defensible language for discussing the ranking. Instead of saying the engine likes this one, you can say this candidate is strong because alignment and responsiveness are carrying it, but stability is limiting it. So for deeper inspection, the engine has also a debug ladder. The key is to use it progressively and not all at once. So now here we come to L1 to L4 audit ladder, which is the debug mode. So you do not open every layer by default. You can use the lightest layer that answered your question. So L1 is for normalization. It asks, are the signals comparable enough to judge fairly? Then we have L2, which asks what raw behavior is the engine measuring before weights and damping. L3 is for the regime. It asks what context and active weights are applied right now. And L4 is for stability. How did raw scores become damped, gate, gated and visible rankings. So the debug should help you inspect the engine without changing the engine. Turning on a debug view should not change the score, regimes, or rankings. It should only expose what is already happening. So use them as an audit ladder, not as a required or workflow for, let's say, every user. So most of you can operate from summary and explain and debug for surprising behavior, tuning, validation, and proof. Now let us start with the first ladder, the L1 normalization sanity. So we said that this one asks, are these signals comparable enough to judge fairly? So it is not a ranking screen, it is a normalization sanity screen. The goal is to see whether the normalized streams look broadly centered and comparable. So lines should generally oscillate around zero. A rough visual range around plus or minus 2 to plus or minus 2.5 is expected, but not guaranteed on every bar. Flatliness, extreme spikes, or broken looking behavior also deserve your attention. So another common question is why only three lines? This is intentional. L1 view only plots the first three valid indicators because the debug is designed for readability and performance. Um, if every possible line were plotted, the screen would become harder to read and less useful. So most of the time you are looking at the top three ranking. So the correct reading of L1 is, do these sources look normalized enough to compare? If yes, move on. Do not overinterpret every wiggle and do not use L1 to pick the winner. After scale sanity, the next two layers explain what is being measured and what context is active. So L2 and L3, which are related to properties and regime. These are best understood together because they separate measurement from context. L2 shows the raw property behavior, that means PA, RL, ST, SNR, and PS. Uh, as a quick reminder, PA stands for predictive alignment, RL responsiveness, ST stability, SNR signal to noise, and PS for persistence. So these values are pre-weight and pre-damping. In other words, L2 shows what the engine is measuring before regime weights are and before stability smoothing. Then the L3 shows the context engine. It shows the active regime and the active weights. It can also show price efficiency, volatility information, and the context values that explain why the engine is emphasizing certain properties. So the critical distinction is that L2 measures behavior and L3 explains context. Regime changes emphasize, not meaning. So PA still means PA, stability still means stability, responsiveness still means responsiveness, and so on. The engine simply changes how much each property matters depending on the market context. Also, regime is price only, so changing the candidate basket should not change the regime on the same market segment. Ranking can change when the basket changes, but the price context should remain independent from the indicators being ranked. The final audit layer, L4, shows how the engine turns scores into a stable, visible ranking. So it's like a stability microscope, if you want it. It shows how raw scores become damped, gate, and sometimes held. Here you will find the following parameters. Raw is the fresh competitive score. Dump is the EBA smoothed score. Final is the score after penalties and final adjustment. Now L is the current life rank. View tells you whether the row is being shown as held now or updated, and meta tells you whether a row is acting as leader, now, duplicate, or another important role. So, what you should look for: first, look at confidence. Second, check whether updates are being held. And third, check whether damping is calming noisy jumps. In the end, check whether visible change was justified or suppressed. The key insight is that L4 proves the dashboard is not merely ranking, it is also deciding when a visible change deserves to be shown. So that is the anti-flicker layer. It protects you from false precision without changing the underlying score definition. So L4 is not really a beginner mode. It's more like an audit view for stability and trust. Now, before we move into validation, let us quickly clear up the most common misreads. So, most confusion comes from asking the right screen the wrong question. First question, why only three Z lines? Because L1 intentionally plots only the first three valid indicators for readability and performance. The second one, why can leader differ from now? So that is because low confidence can freeze the visible leader while the current live winner changes underneath. The third question, why does the score move but the rank does not? So that is because the stability layer may hold the visible order until confidence is high enough. And the last one, does debug change the engine? Of course, not. Debug is read-only observability. It should never affect score, regimes, or rankings. It is there just to help you understand what is happening on the ranking score. So this is also a good moment to reinforce the uh, again the quick glossary: PA, predictive alignment, here responsiveness, AST stability, SNR signal to noise, and PS persistence. After that, as you saw in the first session, you can turn off the table with the acronyms in the indicator. Also, just to mention again, held means the visible ranking is frozen, now means the current live winner, and duplicate means the row is a follower of a canonical source, not an independent competitor. So now that the dashboard is readable, we can move to the trust story behind it. So the engine is not um, trusted because it looks smart. It should be trusted because critical behaviors have explicit pass criteria. There are four trust pillars. First, a formal test plan, including manual and deterministic checks. Second, a debug mode specification, so behavior can be observed visually and numerically. Third, automated sanity checks inside the fine logic. And fourth, presentation mapping, so the proof strategy can be taught clearly. So before release, we have assured that if any of these critical tests fails, the framework is not release ready. So validation is our gate for this point, not just a decoration. It helps us avoid hidden assumptions, and it helps avoid black box behavior that you don't want to see on this kind of indicator. So the idea when we have built this meta indicator is for you to have all the informations regarding the scoring, the ranking, and everything that appear in that indicator, even if you have or not the code behind the indicator. Now, let's see. So the validation plan covers release hygiene plus five behavioral phases. We have the P0 is the pre-flight integrity. So this includes compiled behavior, defaults, debug neutrality, and the minimum valid input gain. Then we have phase A, which is for input safety. This includes flat input, no data input, delayed history, duplicates, explosion stress, and so on. Phase B is related to normalization fairness, so this includes scale neutrality, robust mode, and amplitude fairness. Phase C is related to property logic, so this checks whether those five properties behave according to their intended meaning. Phase D is for the regime behavior and isolation. So this checks whether trend, range, and volatile states are observed correctly and whether regime remains price driven. And the last one, the phase E, is stability and non-repaint behavior. So this checks replay behavior, flicker stress, confidence threshold behavior, and the difference between live state and visible health state. So the point is not that every of you must reproduce every test. The point is that every layer has its own proof burden. Trust grows when every layer has a specific thing and it must be proved. So let us start with the first proof category, the pre-flight integrity. So before the engine can be useful enough, it must be safe to load, safe to inspect, and honest about when it cannot run. So this slide shows the first proof category related to compile behavior, default behavior, debug neutrality, and the minimum valid input gate. The first result is the default run. This proves that the engine loads cleanly on final publication defaults. The second one is summary view. So this proves that the normal user-facing dashboard can display the ranking cleanly without needing debug tools. Also, summary view is the practical everyday view, so it must work without extra complexity. The third result is diagnostic view. So this proves that deeper inspection is available when you need more details. So diagnostics should expose the score path and rank behavior, but it should not change the ranking logic. The fourth result is the L1 debug. So this proves that the debug can be turned on for audit purposes without breaking or mutating the engine. So debug must be read-only observability. The minimum valid input gate is also important in this phase because competitive ranking is impossible with fewer than two valid unique inputs. So if fewer than two valid unique candidates remain, the engine should suspend scoring instead of pretending that a real competition exists. So the message is quite simple. Before the engine can be trusted as a ranking tool, it must first prove that it loads safely, displays safely, allows inspection safely, and refuses to rank when ranking would be dishonest. Next, phase A, test how the engine handles broken, invalid, or redundant inputs. So on this slide, it will be shown several cases where the engine should not blindly score whatever it receives. So the first result is the A1, the flat input. A constant source should be excluded as flat. So we just basically put on the input a constant value. So if a line does not move, it cannot provide useful behavior information. It should not receive a normal competitive score just because it exists. We can see that const 1 was excluded correctly as flat. The second one is related to not applicable input. So like a no data source should be excluded as indicated in the table with the NA. So this proves that the missing data does not leak into the scoring process and does not create fake evidence. So here the NA input was excluded correctly with status NA. No priorities were computed. Other valid indicators remained unaffected. The third result is related to delay history. So this result shows that a delayed or history limited source should stay invalid until it has enough bars to be judged properly. Then, once enough history exists, it can become valid naturally. So, the engine should not judge a candidate too early. The fourth result, the duplicate collapse. So exact duplicates should collapse into a single canonical source instead of creating artificial confirmation. So this is very important because if the same information appears twice, that should not count as two independent pieces of evidence. Otherwise, you could accidentally boost one idea just by loading duplicate or near duplicate inputs. So duplicate input neutrality is confirmed for this test as well. The duplicate slot produced identical scores related to the five properties, which is normal for, let's say, I don't know what is here, SMA 100. No, it's EMEA 15. So it should have the same score and also highlighted as a duplicate. Also, identical raw dump final score as its root while being marked as duplicate rather than receiving an independent competitive rank. Also, you can see a minor detail in the table. Unique over active. So we have 4 out of 5 confirms duplicate collapse without artificial boost. So in our ranking system, we consider just 4 inputs out of 5. And the last test, the explosion guard. So explosive or unstable sources should be contained or excluded. So this protects the ranking from pathological inputs that could distort the score table. We can see the expected behavior. So phase I is where the engine proves that it knows when not to score nonsense. Invalid, redundant, or pathological inputs must fail safely. The engine should not reward broken data, missing data, duplicate data, or unstable data. So once input safety is covered, the next question is fairness. Are different signals being made comparable before scoring? So here comes the phase B. So on this slide, we'll explain whether pre-processing removes scale bias before scoring begins. So if normalization is broken, the ranking can be biased by raw scale or raw amplitude. For example, price, RSI, and volume naturally live on completely different scales. So price might be in thousands, RSI is bounded between 0 and 100, and volume can be much larger. So without normalization, one source could dominate simply because its raw numbers are larger. That would not be good for our ranking system. So the first result, scale neutrality. Uh, this proves that sources like price and RSI can be normalized onto a comparable centered scale. The point is not that they become identical. The point is that they become fair enough to compare. We can see that close and RSI 14 normalized to comparable z-score ranges around 0 on the same axis. So no obvious scale mismatch or pre-processing failure observed in this case. The second and third results are for robust off and robust on. So these results show the effect of robust normalization. When the robust mode is off, spike heavy or heavy tailed sources may appear more aggressive. When robust mode is on, those extreme moves are tamed so that one spike does not dominate the whole comparison. Uh, so that's why with robust Z off, the spike heavy source like high amp that we used ranked as first, and with robust Z-on, it dropped to the fourth on the ranking system, while RSI and close moved ahead and volatility did not dominate. So this supports the expected B2 behavior that robust normalization stabilizes heavy-tailed inputs and reduces their undue influence on ranking. The fourth result is the B3, so the amplitude fairness. Here, we check that high amplitude alone does not create an unfair advantage. So a noisy source should not win just because it swings more. The ranking preference must come from behavioral quality, not raw units or raw amplitude. So here we have used the low amp smooth and high amp noisy, two inputs normalized onto a comparable shared z-scale, and we can see that low amp smooth ranked above the high amp noisy, showing that raw amplitude did not create an unfair advantage. So property table confirmed smoother behavior was rewarded and noisier behavior was penalized, especially via the two properties, so the signal to noise and persistence. So the takeaway from phase B is that the meta ranker should rank structural usefulness, not scale, not units, and not loudness. After this normalization, the next question is whether the five properties actually behave according to intended meaning. So here comes the phase C. So the validation work on this must prove that those dimensions are not just decorative labels. The first result is C1, noise versus trend. So this checks whether a clean trend behaves better than obvious noise on trend-friendly behavior. A smooth moving average should generally behave better than noise on properties such as responsiveness, signal to noise, and persistence. So um, this does not mean a moving average is always the best candidate. It means the property logic should recognize the difference between structured behavior and obvious randomness. So here we have used the SMA 100 versus an input high with a high amplitude, a random high amplitude. Um, so we can see that SMA 100 ranked above the noisy series and scored higher on RL, SNR, and PS, confirming that the engine rewards cleaner, more persistent movement and penalizes noisy behavior. The second result is for C2, the persistent sanity. This is especially important because predictive alignment must be historical and non-repeating. So PA should test whether the indicator historically aligned with later returns. It must not look into the future in a way that would create fake precision. So this result supports one of the core trust claims that PA must be loud, historical, and honest. So PA was non-zero and differentiated across inputs. The SMA 100 is stronger than high amp, while the pathological spike source was excluded as explosion. So this supports that PA is behaving plausibly under the actual pre-processing pipeline and is not obviously broken or stuck at zero. The third result is C3, persistence. So this checks the oscillators do not masquerade as a persistent trend. An oscillator can be useful, but its behavior is often cyclical or mean reverting. So it should not falsely appear as a trend persistent source if that is not what it is doing. So here we have used a simple sinusoidal signal oscillator and a sawtooth signal. So here we can see both of them have a negative persistence, minus 0.15, while SMA 100 remained strongly positive on PS 0.89. So, in a confirmed trend regime, sign ranked below SMA, validating persistence polarity and expected lower ranking of oscillatory inputs during trend condition. The fourth result is the C4 and C5, which is related to separation. So this checks that ST, SNR, and RL remain distinct and bounded, because if all five dimensions collapse into the same measurement, the model would only look multidimensional without truly being multidimensional. So ST and SNR show real separation. High amp slightly higher on ST, low amp it's clearly higher on signal to noise, so the properties are not duplicates. Also, the high amp input did not produce an inflated um, responsiveness value. You can see it's 0.01, and also low amp remained low and is 0.03. So this confirms the responsiveness is not approaching to one on noisy inputs and passes the RL boundary sanity check. So phase C proves that the property math is not just a vocabulary thing. The properties must behave logically, separately, and in line with their intended meanings. So, after the property logic comes one of the strongest stories regarding the validation plan. Now we can talk about regime behavior and isolation. Um, so this slide proves that context comes from price only, not from the indicator basket. So the candidates are being judged under a market context. They should not be allowed to define the context that judges them. So the first result, the D1 trend, this shows that the engine can identify a clear trend segment as trend. In that environment, the weighting logic can emphasize properties that matter more in directional structure. Uh, Bitcoin breakout test produced trend regime with efficiency ratio 0.33, so higher than the threshold 0.3. Also, the debug layer L3 weights match the trend profile, so PA 0.3, responsiveness 0.25, and persistence 0.2, and trend-like indicators ranked at the top. Visible ordering was in health mode, which is consistent with the confidence gating or the stability layer. Then we have the D2, the range. So this shows that the engine can identify sideways or range-like behavior. So in that environment, the engine should care more about stability and signal quality, because the danger is getting fooled by noise. So range regime detection passed. As we can see, the efficiency ratio is lower than the threshold, lower than 0.15, and also the debug layer L3 weights match the range profile. So ST 0.3 and signal to noise 0.25. After that, we have the D3, the volatile. So this shows the volatility override. When volatility expands sharply, the engine can recognize stress conditions and adjust visible behavior accordingly. So also the volatility shock validation is passed here. It's an internal engine for this kind of behavior. So we can see the regime switch to volatile via the ATR based override. ATR percentage is 1.4, and also the debug mode L3 showed the correct volatile weight profile. Um, Also, we have here the L4 debug mode, which confirms stress behavior to a health view and moderated adaptation under low lower confidence, which matches the intended stability focused handling in volatile conditions. The last one, we have the D4, the isolation. So this is the most important result on this slide. The isolation audit means that when the indicator basket is swapped on the same price segment, the regime should not be redefined by the new basket. So here, regime remained volatile with the same efficiency ratio after swapping from an oscillator or volume basket to a trend heavy basket on the same segment. Ranking changed between runs, but that is expected and desirable. The basket changed while the price driven regime did not. This confirms regime detection is isolated from indicator family selection and is driven by price only inputs. Also, ranking can change when the basket changes. That is normal, but the regime should remain price driven. This protects the framework from circular logic. So the takeaway from phase D is market context is independent from the candidate basket. The engine can rank different baskets under the same price derived context without letting the basket contaminate the regime. Now we can move to the most visible life behavior phase, stability and non-repeat behavior. So this slide explains how the visible ranking behaves under uncertainty. The first result is I1, flicker stress. So this shows what happens in choppy or low confidence conditions. In this kind of environment, the life winner underneath can change frequently, but the visible leader may stay held. That is the anti-flicker layer doing its job. So leader and now can differ without contradiction. Leader is the stable, visible claim. Now is the current life winner underneath. In choppy range conditions, so we can see efficiency ratio 0.11, confidence dropped to 12.5. So the dashboard entered health mode and the visible leader WMA20 remains stable while the current highest candidate stochastic differed underneath. Hold bars 151 confirms that the stability layer suppressed rank flicker rather than allowing rapid visible turnover. The second result, we have the low threshold. So this shows that when the confidence threshold is lower, the table become more responsive. So the visible ranking can update more easily. And the last one, the high threshold, shows that when the confidence threshold is higher, the table becomes more stable and holds longer. So this proves that the update gate is rule-based and controllable. The dashboard is not randomly twitchy or randomly frozen. It is responding to explicit stability rules. This is also where the non-repaint is proven because the tool should not hallucinate precision. It should show uncertainty honestly. So that is why health is important. That is why confidence is important, and that is why we have the L4 debug mode. So the goal is not a table that changes constantly. The goal is a table that changes when evidence is strong enough to justify visible update. So using the same noisy short time frame basket and chart segment, I swept the confidence threshold at 0.05 with life confidence at 10%. So the engine moved to updated state and hold bars reset to zero, showing increased responsiveness. At a threshold of 0.15, with the same confidence level, the engine remained held and accumulated hold bars, showing increased stability. So this matches the intended threshold gating logic and demonstrates that hold or update behavior is rule-based rather than random. In the end, we can summarize the validation story. So from P0, we saw that the engine must load cleanly, display safely, preserve debug neutrality, and suspend scoring honestly when competitive ranking is impossible. From phase A, we saw that broken, invalid, duplicate, delayed, or explosive input must fail safely. Phase B, we saw that normalization must make different sources comparable so that ranking is not biased by row scale or amplitude. From phase C, we saw that the five properties must behave according to their intended meaning. Phase D, we saw that regime is price only and should not be contaminated by the indicator basket. And phase E, we saw that visible ranking behavior is stability aware, confidence gated, and no non-repeating. So what was proven, the indicator compiles cleanly and suspends scoring honestly. Broken input fails safely, normalization and properties behave logically, regime is price only, stability is control and rule based. So based on this meta indicator, you will get a transparent ranking instead of signal teeter. Confidence aware visible updates, explainability through tables and debug layers, honest uncertainty instead of false precision. So it does not generate any buy or sell signals. It does not repaint. It does not rely on hidden assumptions. It does not use ML opacity or taxonomic bias. So MCDA is quite narrow, explicit, reproducible ranking engine. It does not ask you to blindly believe the output. It gives you the way to read it, explain it, audit it, and understand when the engine is confident enough to change the visible ranking. So basically, in session one, we learned how to configure the comparison. And in session two, today, we learn how to read, audit, and validate the comparison. The practical takeaway, start with the header, use summary for speed, use explain for meaning, use diagnostic, and debug only when you need audit depth. And always remember the meta indicators rank candidate sensors. So it does not replace your trading system. Thank you everyone. That is for this indicator. I am really excited um, to finish it. I hope it will be released soon so that you can start to play around with it and gives us some feedback regarding your outputs. Thank you.
Thank you very much, Yuli. Amazing work.
Thank you.
So, yeah, pretty excited about, I don't know, finishing this suite of indicators and strategies and all together. I think as of next week, we are going to start the mixing of them. And also, I'm going to promise you guys, we are also going to start. We are going to also start publishing them. Yuli, I believe I have an idea. Not
Okay.
sure if it's feasible at the moment, but what do you think of sharing with everybody an early look of the MC? Let me remember the name,
MCDA,
MCTA. Exactly,
multi-criteria decision analysis.
exactly. What if in about, I don't know, 24 hours or something like that, we can share like an early look to everybody and yeah, have a look until we start to publish everything else.
Well, I think that is more on you, not on me, because it's an administrative task. So,
Let's do this. I mean, let's do this. Let's give everybody a formula to fill in their TradingView ID, their Discord ID, so we know exactly uh, who's catching it. So if you guys are a member within the community, either a free subscription or a paid subscription, you're going to get access of this amazing work that Yuli has managed to do in how many months working here and there? 4 months, 3 months?
Yeah, it was like two, I think, 2 months, but yeah, it was not a 24 out of 24 work, but consistently working on it, and yeah, also work a lot on the validation part because, as you saw, it's really transparent and it should not try to fool you on the regarding the score. So it should really help you making a better decision, and that's it. It doesn't mean it's the best decision, but it definitely improve your strategies. So yeah, something like that.
Awesome. I mean, let's do this. I just shared with everybody a formula on which they have to just share the TradingView ID and the
Okay.
Discord ID. So we make sure they are pretty much part of the Discord community. And that's pretty much it. I think we can wrap like a public release, of course, like an early look of a public release in 24 hours or so. So either by the end of tomorrow or in the morning in next 2 days. So anywhere within that interval, I believe Yuli can polish if there is any need to do that. So I can actually add you guys to the indicator. Hope you guys like this decision of an early look. And of course,
Perfect.
as of the next one, we are going to start publishing everything through TradingView. So make sure, guys, to have a look on our announcements channel because I'm going to announce it as soon as it's live over TradingView. All right. Again, Yuli, thank you very, very much for the presentation. It wasn't
Thank you.
the it wasn't the shortest one, but
Yeah,
I hope that everybody got
I
some
just
value right there.
saw I just saw the time. I'm sorry for that. I'm used to to talk alone for like 1 or 2 hours in my courses. So
No, no, it's perfect. It's perfect. At least you don't have to move and write on the table, right? It's all good. Algabot, great word, Yuli. So in depth. Indeed, indeed, indeed. And cannot wait you guys to have also access to these amazing, amazing indicators and also strategies. Again, they are going to be published in the next week. We are starting with maybe like a couple every week. So they're going to be released in batches and make sure to upload them over TradingView as well. So that's pretty much it, guys, for today in a matter of main events and also within this week. Again, huge Discord refresh, guys. We have also another room which would be ready, I believe, in the next couple of hours or tomorrow. Operator is joining with us within a new room inside the Discord. He's going to do a little bit of helping you guys setting up the strategies. So everything starting from optimizations, how to actually optimize, understanding a little bit how optimizing works, pretty much getting started with the David Tech strategies, so to speak. He also has free hand, I suppose, in order to do whatever he decides to. I'm sure that you guys will have a lot of value by just following his room inside Discord. And yeah, that's pretty much it, guys. Also, another huge news, Trader Dev got updated. I believe that now, at the moment, the parity of TradingView candle data is higher than 99%. There are still a couple of mismatches because of the broker inside TradingView, because TradingView, for some reason, it doesn't match the broker data that's getting the data from, but we're also getting the data from that particular broker. So if you're going to select Wanda, you're going to have the data of 100% pegged to it. Crypto, it's 100% working. We do have Bybit, and I believe Binance is also joining along. So one of the two, you just have to choose, and the data should be at least 99%, 99% one-to-one. So yeah, I suppose these very, very weird issues of big companies like TradingView getting their data, and for some reason it's not one to one with the data that they are getting from. it's a little bit out of my thinking, like why exactly is different. However, with crypto, we tried with the indicators. For example, we have tested the ATR and RSI values within all of the candles, and the results were 100%. Let's just call it 99.99%, because maybe there could be like a candle missed here and there, but who knows, like an outage or whatever. But yeah, other than that, I believe it's a big update. Finally, we got rid of that 5 or so percent error, which is indeed quite huge. I tend to agree with you guys. But yeah, all issues have been fixed, at least close to 99% on some isolated case. Of course, crypto, which is the main interest, I believe, on our community, it's very, very close to 100%, so higher than 99%. If you guys still have any issues, do not hesitate to contact us over the WhatsApp channels. Either me, Rudy, or David will be in touch with you if you have any issues to see what we can do about them. All right. I believe that's pretty much it, guys, with the main topics for today. I'm going to do a short performance update. In case you guys have any questions, please feel free to write them down in the chat. So, performance update, as you guys might be already familiar, we are in the top traders, top copy traders, leaderboards within various exchanges. Some of us have been notified that they are in the top 1%. For example, a public example right here, we have Fishing, the creator of Trade Harbor, the best David Tech dashboard we never had, has been notified he's in the top 1.3% traders within Bybit. You can also see the success of Reed, Wen Moon. They both have actually a room inside Discord. Reed in particular, he's a very good trader, an algo trader, also very good copy trader. You can see definitely some success. Over 100% PNL, over 60% ROI over bluffing. If I'm not mistaken, bluffing to the left, 2B to the right. And yeah, feel free to check, guys, out the Trade Harbor. You can see a couple of people are having some challenges. For example, He Fishing has a $1,000 challenge. Also, Reed has linked one of his bot sub accounts to Trade Harbor, so you can watch their performance live. And that's pretty much it, guys, for today and also for this week with the live streams. Make sure to join our Discord server if you wish to stay in touch with our community. Let me share that. The link is also in the description. Also, if you wish to check out our bot, strategyfactory.ai, it's a huge, huge platform with so many bots. That's pretty much it, guys. Thank you very, very much for being here. Yuli, thank you very much again for being here.
Thank you, Vlad. Thank you, everyone.
All right. Thank you very much, everybody. And also the 15 people watching us over X, YouTube, and Twitch. Make sure to join our Discord server for the next live stream. Goodbye, everyone. See you next week. Cheers.